Hi everyone, I want to make a quick video to review how we can compose functions and also find the domain of a composite function. And I just want to say I'm recording this video at home. It's almost bedtime for my 3-year-old. So if you hear a bunch of commotion, please forgive me. I'm going to try to make this quick. All right, so let's look at the function f of x equals x squared plus 3. And then let's define g of x as the square root of 8 minus x. All right, let's find first f of g of x. Okay, so here's the deal. We know that f of x equals x squared plus 3 and g of x equals the square root of 8 minus x. So finding f of g of x is the same as finding f of whatever g of x equals, and in this case, g of x is the function the square root of 8 minus x. So this means we're going to take the value or the function, the square root of 8 minus x, and we're going to substitute it into f. We're going to take the square root of 8 minus x, and we're going to substitute it into f in place of the x. Okay? So then our function f of the square root of 8 minus x will equal the square root of 8 minus x squared plus 3. The square root of 8 minus x and the squared are inverse operations. They will cancel each other out. And you're going to be left with 8 minus x plus 3. Combine our like terms, and we will have the composite function f of g of x. So again, we had f of g of x equals what was just on the last screen, which was 8 minus x plus 3. Combine like terms like I already mentioned. And 8 plus 3 is 11. We have nothing to combine with the negative x. So f of g of x is 11 minus x. So f of g of x equaled 11 minus x. But when we talk about its domain, we have a few things to consider. First, we need to remember what g of x was defined as. G of x was the square root of 8 minus x, and f of x was x squared plus 3. Let's talk about the domains of each one of these. First, let's consider the domain of f of x. The domain of f of x, there are no restrictions. We can input any number that we want into f. We can square it and add 3 and get out a real number. So the domain of f would be all real numbers. But what about the domain of g? We have to remember when we're talking about this composition that g becomes our new input for f. Okay? So what does that mean? That means that whatever we put into g determines its output, and the output of g becomes the new input for f when we compose the functions, because we are putting g into f. So we need to analyze what the domain of g is. G is a radical, and we know that we're only discussing real numbers up to this point in the course. So we have a special case because we have a radical. What's underneath the radical sign has to remain positive. So that's going to determine our restrictions. We want 8 minus x to be positive, so it needs to be bigger than or equal to 0. We're going to solve this inequality. We will subtract 8 from both sides. and we have negative x is greater than or equal to negative 8. When we divide both sides of this inequality by negative 1, we then have, let me make some more room, excuse me. We then have x is less than or equal to positive 8. So this is the restriction that we need to impose because, again, the output for G became the new input for F. So the domain of f of g of x was or is x needs to be smaller than or equal to positive 8. And if we write it in interval notation, let me erase some of this stuff off the screen. Looks messy. Okay. So if we write it in interval notation, we're going to write it as negative infinity to positive 8, and the 8 is included because x needs to be smaller than or equal to a positive 8. Now we'll do the other composition. We're going to find g of f of x. G of f of x is going to equal g of x squared plus 3 because x squared plus 3 is what f actually equals. So we're going to take the value of x squared plus 3 and substitute it into g in the place of the x that we saw. So I'm going to rewrite what g and f were on the screen just to refresh our memories. I'll try to use different colors. So g of x was equal to the square root of 8 minus x, and f of x equaled x squared plus 3. So when we found g of f of x, we're taking the x squared plus 3, and we're substituting it into g in the place of the x that we see. So g of f of x, or g of x squared plus 3, is going to be defined as the square root of 8 minus what is circled in red. And I'm going to enclose it in parentheses to make sure that we have substituted it in properly. Okay, and now we need to distribute our negative sign and go ahead and simplify. So this will equal the square root of 8 minus x squared minus 3. Sorry, y'all. I'm writing in a Word document because I don't have the whiteboard or anything like that on my computer at home. So please bear with me. I hope you're still able to follow this video. Okay. So now, we need to go ahead and simplify. That's where I was. So 8 minus 3 is 5. So g of f of x equals 5 minus x squared. Now we need to determine the domain of g of f of x. Remember, the input for f was all real numbers, okay? And the output would also be all real numbers. But the domain of g told us something else. The domain of g said that whatever we're putting in for f, because we're plugging in f into g, had to be less than or equal to 8. So what does that mean? The domain for g was x is less than or equal to 8. And because we are now using a different function, we're putting it into G, we still have to consider that original domain of G, okay? But also we know that this means f of x has to be smaller than or equal to 8. So there are a couple of ways that you can do this to find the domain of the composite function. They're actually kind of similar. You can either look at the domain of this function that I'm circling in green, okay? Or we can say we know that we want f of x, which was equal to x squared plus 3, to be smaller than or equal to 8, because the domain of, or the restriction that was placed on G was that x had to be smaller than or equal to 8. And now we just solve this inequality. So when we're solving this inequality, subtract 3 from both sides, and we find that x squared needs to be smaller than or equal to 5. And we haven't talked about solving quadratics yet, okay? But I'll just let you know that when you solve this quadratic, you're going to get an interval. We have to take the square root of both sides. And when we're solving the quadratic, it would be, let me see if I can find some room. Let me erase this. Sorry again, guys. Let me erase this. I'm trying not to move the rectangle. Okay. I'm writing in green. There we go. This would look like the negative square root of 5 is less than or equal to x, and x is less than or equal to square root of 5. Because this guy right here, when we solve the quadratic, we would have x, oh gosh, it's so messy, sorry, is less than or equal to square root of 5, and then x is greater than or equal to the negative square root of 5. Okay? So then if I write this domain in interval notation, it will look like the negative square root of 5 in brackets, comma, square root of 5, and another set of brackets. And this is the domain of G of f of x.